In my hand is a power supply module designed for servers. It is truly a beast, capable of delivering nearly 190 at 12 volts. Today I will take it apart to show you what's inside. I also plan to replicate part of its circuitry. You can see that its internal structure consists of 3 modules connected together by cables. These include an EMI filtering and rectification module that converts 220 VAC to about 310 volt DC. The DC voltage is then fed into this compact PFC module. Although small, it can easily handle a power level of around 2,500 watts. Next, the 400 volt DC output from the PFC stage is delivered to the DC-DC module. This module uses 4 H-bridges, driving 4 high-frequency transformers, combined with synchronous rectification. Thanks to this design, it can deliver up to 190 amps of output current while using a relatively small heatsink. In this video, I will focus on the PFC module. I will try to design a PFC module based on the design used in this power supply. Let's get started. I would like to give my sincere thanks to JLCPCB. They have generously sponsored PCBs for many of my projects. Many of my projects probably would not have been possible without their support. I will show you the simplest way to order PCBs from JLCPCB. First, you need to register an account. You can sign up quickly using the link I placed below this video. Then upload the Gerber file that I provide. Once the Gerber file is uploaded successfully, you can check the PCB one last time using the built-in 3D viewer. This tool is very useful. You can easily check for design errors and preview how your PCB will look after it is manufactured. Next, you can choose the PCB color, PCB material, and many other parameters. After everything is complete, you can add it to your cart and proceed with payment. Don't forget to apply the discount codes so you can optimize your PCB cost. JLCPCB is currently offering great promotions for 6-layer PCBs. If you have any 6-layer PCB projects, don't forget to sign up and take advantage of these excellent offers. Just like all my previous orders, the PCB quality is still excellent. I received the boards in only 2 weeks, which is very fast compared to many other companies. I will start assembling this module. This is only a prototype version, so the PCB size is quite large, making it easier for me to debug. Later, I will reduce its size. I'll start with the power supply section. This 12-volt supply block will power all the other sections, including the protection circuit, the control circuit, and the cooling fan. The power module uses the TNY290PG IC, which has a very wide operating voltage range. It can even start up with an input voltage of just a few dozen volts. Most of the components are very common and can be easily purchased on the market. I have also clearly labeled their names, so I think it will be easy for you to follow along. This module can operate with both AC and DC input voltage. As you can see here, I am connecting it to the 220-volt mains. The output voltage is regulated around 380 volts, which is perfect for supplying power to a DC-AC H bridge. There are many possible applications for this circuit. First, it can improve the power factor when combined with DC-DC power supply circuits, helping to reduce noise, increase efficiency, and lower reactive power in power systems. It can also be used in electronic voltage stabilizers. Even if the input drops below 100 VAC, the output can still be maintained at around 220 volts. The response speed is much faster than traditional voltage stabilizers that use carbon brushes. In addition, it can be used as a boost stage in solar power systems or to simulate a PV source for grid tie applications at night, and many other uses. It can also work well with DC power sources such as batteries or solar panels. Here I'm connecting it to my solar panel. With an input voltage of around 280 volts and the output regulated at about 350 volts, it works perfectly.